Good evening, ladies and gentlemen. It's about 6 o'clock. I'm back in my classroom to record these videos for you. This video I'm going to do adding and subtracting fractions. I tried to do it a little bit in class, but we ran out of time, so watch this video. Let's go forward. Let's see what's going to happen. Oh, okay. First thing, we should just go by what the rules are for adding fractions. If in fact you are adding fractions, remember that the denominators have to be the same for you to combine them. Same thing here with you have a over c plus b over c is going to equal a plus b over c. So the denominators have to be the same in order to add these things. Here's an example to actually show you what it's going to look like. Let me get my pen ready. As long as the denominators are the same, we're okay. Same thing for subtraction. As long as the denominators are the same, we can actually subtract those fractions. So it should look like that. Here's another example of it, this time using subtraction to show you as long as the denominators are the same, we can subtract them. Other examples, since this is Algebra 2, we're going to be actually doing some more elaborate problems with 2 and 3 and maybe even 4 add-ins. So say, for example, here, if in fact you're doing 4 15ths plus 13 15ths plus 7 15ths, since the denominators are the same, then we should be able to add all three of them. So that means 4 plus 13 plus 7 all over 15, right? And when that's all said and done, you should get 24 over 15. No problem. Let's try another one. Let's make it a little bit more algebraic-y. That's my word. When we're combining these two, notice that the denominators are the same. So since the denominators are the same, we can subtract here. But in this case, what I'd like you guys to do is I'd like you to not skip this step. So we're going to actually subtract it straight across. Now remember, it's like this, there's parentheses around here, so this subtraction sign has to go to both terms. So you have 3x squared minus 8 minus x squared plus 9. And this is going to be over x plus 2 because you keep the denominator the same, right? So then what is all of that going to equal? Combining our terms, we get 2x plus 1, I believe, over x plus 2. Now, it's going to come a point in time where you're going to have to simplify these. Oh, I'm sorry, this is 2x squared. There's going to come a point in time where you're going to have to simplify these. In this case, right now, we can't simplify, but later on, we will. Now, it's not going to always be easy having the same denominator. There's going to be some times where you're going to have different denominators. And in this case, we're going to have to find the LCD, the lowest common denominator. All the lowest common denominator is the lowest common multiple of the denominators. So another thing to know is what you want to do is you want to express each fraction as an equivalent fraction with the LCD as the denominator. For instance, if in fact you have 1/2 and 1/3, and you wanted the LCD of these, you want them both to be equivalent. So in this case, if I multiply this by 3 over 3 and I multiply this by 2 over 2, then that means both of these can actually be placed over 6. So you'd have 3 over 6, and in this case you'd have 2 over 6. And it's still equivalent fractions. Why? Because all we're doing is multiplying by 1. So that's what we mean by that. And then after that, you add, subtract, and then simplify. Remember I said that you're always going to have to simplify, right? So let's go to an example. Looking at this right here, the LCD of this fraction right here, quick way to actually find it, not the common denominator, but the least common denominator, is what if I prime factorized each one of these numbers? So 42 can be prime factorized into 2 times 3 times 7, right? And 18 can be prime factorized into 2 times 3 times 3. Right? And this 2 right here is just over 1. So we don't really have to worry about that one. So looking at this, it's the same way when we were finding LCMs. Who has the most and how many do they have? Each of them have 1, 2. So when we're talking about our LCD, it's going to be 1, 2, 2 3s, and 1 7. If in fact we multiply that all together, we should get 126. So that would be just the LCD. If in fact they're just asking for the LCD, then that's all we have to worry about. So let's keep on going and see if in fact we can simplify this. If we're subtracting, adding these three fractions together, remember we want to know what the LCD is first. So looking at them, you have that 6a squared, you have 2ab, and you have 8b squared. Now, if in fact we're trying to find out what the LCD of these, just break them up. You have here 2 times 3 times a times a. Here you have 2 times a times b. Here you have 2 times 2 times 2 times b times b. If you need to do a factor tree to figure those out, please go right ahead. So from here, the only factors we're dealing with are 2s, 3s, a's, and b's. First off, who has the most 2s? This does. It has 3 of them. So when we're doing our LCD, we have that many 2s. Who has the most 3s? This one has 1 3, so we have 1 3. Who has the most a's? Up here, that means 2 a's. And who has the most b's? That means 2 b's. Let me put a multiplication. So when we put all of that together, that's going to be 24 a squared b squared, which is our LCD. So since that's our LCD, each one of these fractions is going to be placed, over 24a squared b squared. So we'll do that. Now, looking at that, we have to find out what we had to multiply each one of these denominators by to get 24a squared b squared. Here, I multiplied 6a squared. By 4b squared. That should give me. And whatever I do to the bottom, I have to do to the top. Here, so that means that 4b squared times 1 is going to give me 4b squared. Here, what did I multiply 2ab by? I multiply that by 12ab. So whatever I do to the bottom, I got to do to the top. And then 8b squared, I just multiply that by 3a squared. And whatever I do to the bottom, I got to do to the top. So once that happens, my numerator here should be 12ab, and my numerator here should be 9a squared. So then from here, we can actually simplify this. Go ahead and try to simplify that and see what you get. Now, you should have ended up here if, in fact, you combined everything together. But you are not done. Remember in the last part, I said that you have to simplify. So since you have to simplify, we have to go further than this. That means you should have ended up here. If, in fact, you fully simplified, it means you factored and you came here. So you should have ended up that way. All right, let's see. This one right here, I'll just explain this one just so a lot of the problems you're going to do are going to look exactly like this. So when you're trying to simplify this, the first thing you should do is factor that. Once it's factored, you should try to find out what your LCD is. Since it's fully factored, you don't need to just write out. What I suggest is to actually just write out what your LCD is, just so you have an idea. Here, since everything is factored prime, just what does one have that the other one doesn't? And for the most part, this one has an x plus 3. This one has an x minus 1. So you're going to combine all of them. So really, your LCD is going to be x plus 3 times x minus 2 times x minus 1. So now we have to figure out what we have to do to what we have to do to make both of those equivalent fractions or equivalent fractions that look like this with this LCD. So first thing is this. What does this one have? This one right here have that this one doesn't. This one doesn't have an x minus 1, so we multiply this by x minus 1. And whatever you do to the bottom, you have to do to the top. Over here is the same idea. Whatever you do to the bottom, over here I'm multiplying by x plus 3 because this doesn't have an x plus 3. I got to multiply to the top. So work that out and see what you get, meaning pause the video and just work this out and just to see what you get so you can match up with what I get. This should be your next line, or what it looks like. And this should be your next line right here. So as we work this out, or as we combine our terms, we should get x minus 6 over x plus 3 times x minus 2 times x minus 1. So this is the idea behind trying to simplify these fractions. We will do more of these in due time. Try this one on your own and see if, once again, if you can match your answers up with mine. So pause the video, work this one out, and then press play again and see what I got. This is what I ended up with. So match your answers up with me and see what happened. I'll explain real quick. I found the LCD to be y times 2x minus 3y squared because over here, there's two factors of 2x minus 3y over here, and then there's a 2x minus 3y and a y. So the only thing that's missing from this side that this one doesn't have is a y, and the only thing missing from this side is a 2x minus 3y. So altogether, you should have y times 2x minus 3y squared. So then from there, it's just factoring, just regular algebra, and we should end up with something like this. So that will conclude this video. We'll do some more work in class.